Modern meat processors are increasingly using least cost formulation, also known as LCF, to optimize their production. This webinar explains what LCF is, how to calculate it, and key factors to consider for cost breakdown. It outlines how inline fat analysis systems have opened the door to this mathematical formula by providing precise chemical lean measurements. Watch and discover how LCF can help meat processors increase their bottom line margins, maximize profits, and produce consistently high-quality products. For meat processors, making the most of raw material results in yield improvement with increased margins. If inventory isn't maximized to its entirety, opportunities are lost, as well as potential revenue. To ensure ingredients are maximized to their fullest, a formula exists called least cost formulation. LCF enables meat processors to create a formula or recipe at the least cost. It specifically applies when a formula or recipe must meet certain technical parameters and constraints, and where there's flexibility in ingredient use in meeting those parameters. When using LCF, meat processors must consider several factors, including variability in the composition of raw materials, availability of raw materials, cost of raw materials, and the demand on production. LCF looks at all the different costs associated with producing a final product, including current inventory, and identifies which combination and proportion will result in the lowest cost at time of production. Importantly, still producing the final product to the same quality. As fat content is a primary determiner of the cost of meat, the ability to measure fat content accurately is crucial to effective LCF, and this is where the advanced X-ray technology behind inline fat analysis comes into play. Modern FA systems use dual-energy X-ray absorptiometry, or DEXA, to scan through meat passing through the system. DEXA works by measuring the differential absorbency of two X-ray energy spectra to measure fat content. This means that 100% of the meat that goes into the batch is scanned to yield the fat measurement, measuring 100% of the meat at accuracies better than plus or minus 1 cl, or chemical lean, enables LCF control schemes to precisely meet blending targets at lowest cost. In addition, FA systems are simultaneously capable of detecting physical contaminants and measuring weight. These additional capabilities help prevent damage to downstream processing equipment, as well as safeguard companies against product recalls. Furthermore, by providing processors with real-time accumulated weight and weighted CL measurements, FA systems enable control of a total batch to target CL at a given batch weight. LCF looks to capture variability in the price of raw materials, the availability of those raw materials, and demand. It also factors in how orders are scheduled and produced, and at which time in a production run, as well as inventory management considerations and individual supplier contracts. LCF exploits the variability in all these factors to select the combination that yields the lowest cost, and always at the same quality. By itself, implementation of inline FA provides significant savings through standardization and a variety of additional benefits, including cost reduction related to food safety risk, labor reduction, and purchasing surveillance. Combining inline FA with an appropriate LCF control scheme delivers an additional 3 to 5% or more savings on the cost of raw materials. For processors producing 10 to 20 tons daily or more, the savings potential is significant. For effective LCF results, processors require access to data needed to drive the various factors in their LCF model. Some processors will use a manufacturing execution system, also known as MES. Consider a sausage production run. A typical sausage recipe would consist of shoulder, belly, and back fat. All three raw materials will have a natural variation in fat content and market price. FA will capture the fat variation. On an LCF optimized line, the materials create a three-dimensional control space bound by fixed recipe alternatives, A through H, indicating the possible extreme raw material combinations defined by the constraints in the LCF model. The processor must define these constraints to ensure batch-to-batch recipe quality and specification performance is consistent. Examples of constraints include: can't use more than 10 tons of belly fat or must use at least 20% shoulder. This creates the concept of a dynamic recipe, where the recipe can change from batch to batch within this space as the LCF algorithm finds the optimal least cost point within that space. This optimal point at which the recipe can be produced will vary depending on the variability in raw materials. Accurate fat and weight measurements from the FA are critical here to ensure batch-to-batch consistency and recipe quality at the lowest cost per batch. LCF-capable software allows processors to optimize each recipe or batch based on raw materials in inventory. Software communicates with FA systems on the line directly or through plant networks. Data is subsequently interpreted into a convenient dashboard, real-time graphical display of the current batch production versus target recipe. Recipe statistics, including CL, weight, protein, and collagen content, are also displayed in real time. Based on the graph, operators can see how close the batch is to its target recipe requirements and completion. Operators can optimize a recipe with the click of a button. This will calculate the LCF of raw materials available in inventory based on composition, cost, and any constraints to fulfill the current recipe and product. After this optimization, the software then displays the raw materials which must be added to maximize ingredient utilization. Raw materials are the most expensive commodity for meat processors, so increasing effectiveness in their use through processes such as LCF is highly desirable. On new processing lines, LCF integration can be factored into installation planning from the outset. However, most processors will have existing lines and may be wondering where to start. The first step is to install an inline FA system to measure the actual variable composition of the raw materials being processed. FA system suppliers will assist processors in determining the ideal location for the FA so they can capture variability in composition of the raw materials to the greatest advantage for their LCF model. An accurate and reliable FA system is vital as it is a critical element driving measurement data to the LCF control. Inline FA systems are available which measure 100% of product in real time and provide fat analysis to within plus or minus 1 CL or better. FA systems also provide accurate weight measurements, which are important for batch and recipe management. Most FA systems can simultaneously check products for physical contaminants too, providing support for food safety programs such as HACCP. In addition, some FA suppliers offer reject systems specially designed to ensure efficient removal of contaminated product from the product flow, while automatically taking into account the CL and weight of any meat product removed in cumulative batch calculations. Long-term total cost of ownership, TCO, is an important consideration with FA systems as recurring costs related to maintenance, sanitation, and calibration can rapidly add up. When considering an FA system purchase, it's important to look at 1. Sanitation. Is it easy to break down and reassemble for sanitation? How long does that process take, and how many people are required? Is the system designed to be robust against the harsh sanitation protocols typical in meat processing? 2. Ease of use. What's the learning curve for efficient operation of the FA system? 3. Maintenance. How many wear parts are there, and what's their expected lifetime? What's the expected lifetime and replacement cost of the X-ray tube? 4. Calibration. How complex are the calibration and validation procedures, and what special tools are required? How much time is required to perform these tasks? 5. Service and parts. Does the supplier offer technical support 24 hours a day, 7 days a week for service dispatching and replacement parts support? Are parts stocked locally? How many service personnel does the supplier have? How long would it take to get a service engineer on site? Once the FA system is installed, the information can be fed into a processor's recipe management system in LCF control, enabling raw material costs to be controlled with unprecedented accuracy. Results and reports will be reliable and directly tied to cost and profit calculations. This proven connection allows production to run at higher throughputs while making the best use of the inventory available. Close regulation of recipes, including constraints in material usage, produces a consistent, high-quality final product at lowest costs. Since product constraints and costs are tracked, meat processors can take advantage of strategic purchases and spot buys to fulfill existing and future orders, which affords production the agility to utilize materials even if demands change. Additionally, FA systems enable processors to check if all incoming raw material is within purchase specifications and correctly priced. This level of supplier surveillance is valuable with regard to controlling and reducing raw material costs, and can support processors' claims for products that fall outside specifications. The ability of FA to detect physical contaminants early in the production process can also have a direct effect on cost reduction. Not only are contaminated items removed before further values added, removal of contaminants prevents potential damage to processing equipment further downstream. Meat processors who don't take LCF seriously expose themselves to competitive threat from processors who do, and also fail to achieve the highest production yield. Through accurate fat measurement of 100% of the product, inline FA systems enable meat processors to enjoy the benefits of LCF by extracting every ounce of process yield, and thus operating margin from the product they process. For more information on the Eagle FA3 system, visit www.eaglepi.com/FA3. Thank you, and if you'd like to stay up to date with the latest product inspection trends, just follow us on social media. Connect with us on LinkedIn. Follow us on Twitter @EagleXray. Follow us on Google+, and subscribe to our YouTube channel.